Look around you right now. The plastic casing of your pen, the wood in your chair, the cotton shirt you're wearing, even the rice you had for lunch. They all look completely different, but they share the exact same hidden ingredient. That ingredient is carbon. It's so deeply woven into life that 18% of your own body is made out of it. Yet, if you look at the entire planet, carbon makes up barely 0.02% of the Earth's crust. Despite that tiny fraction, it gets an entire branch of science dedicated exclusively to it. Out of all the elements in the universe, why does this specific one hold so much power over the physical world? The answer lies in its personality. Carbon is the most social, easygoing atom around. It's the ultimate team player, always willing to form a bond and hang out with almost anyone. Its true strength comes from this ability to connect. That unique social behavior is exactly how it builds the massive, complex structures that make up our reality.
To understand why it's so social, we have to look at the rules of survival for an atom. Every atom wants one thing: to have exactly 8 electrons in its outermost shell. That's the magic number for an atom to be stable and happy. Carbon faces a specific dilemma. It has exactly 4 outer electrons. Throwing them away takes too much energy. The strong nucleus pulls them back. Stealing extra electrons also fails. The small nucleus bounces them away. Giving or taking 4 is physically impossible. Carbon is locked into this 4-slot middle ground. Because it's stuck exactly halfway to stability, it is forced to invent a completely new way to survive. Carbon comes up with a clever workaround. Instead of fighting to win or lose electrons, it decides to share. It's the atomic version of a clever hack. Think of a classroom check. You slide a single textbook exactly between your and your friend's desks, so you both have what you need. Carbon does the exact same thing. 2 atoms overlap their outer rings and place their electrons right in the middle, counting them toward their goal. We call this mutual sharing a covalent bond. Because both atoms rely on those exact same shared pieces to stay stable, they hold onto each other tightly, creating a highly secure physical link. Since it has those 4 empty slots, it can execute this sharing trick with up to 4 different atoms at the same time. This means a covalent bond acts like a continuous structural joint. Instead of isolating themselves, carbon atoms use these 4 connections to build massive, sprawling networks. As it turns out, carbon's favorite element to share with is actually itself. It uses those bonds to link carbon to carbon to carbon, acting as a flexible backbone. Here is a chain of carbon atoms linking up in a straight line, with hydrogen atoms filling the gaps. It works exactly like Lego blocks. To make a new molecule, just snap on 1 more carbon link and 2 hydrogens, expanding the chain. But you aren't limited to just those simple links. You can pop off a piece at the end and snap on a specialized cluster of atoms instead. Swapping just that one cluster gives the molecule an entirely new behavior. It can change a chain from a piece of rigid plastic into an active medicine. This modular, plug-and-play architecture lets nature construct near-endless variations. That is why carbon is the foundational ingredient for nearly every physical object you interact with. When you take that microscopic view and zoom all the way out, those chains of sharing atoms form the visible world. Carbon doesn't dominate the Earth by hoarding resources or exerting force over other elements. It succeeds strictly through its capacity to connect. Next time you hold a pen, sit on a wooden chair, or share a meal, you are looking at the results of that exact atomic teamwork. The most complex and vital creations in our universe exist entirely because one tiny atom figured out that the best way to survive is simply to share.